Sorry. Hi, my name is Guido. I'm going to introduce Ganeti, which is an open source cluster virtualization management tool we wrote at Google for use in our corporate environment. So first of all, I'm going to do an overview of how to manage a Ganeti cluster and what is it. Then I'll go a bit into the details of how failover internal to Ganeti works, just to show it. And then we'll talk what we're doing on Ganeti. I'll have convinced you by that time to use Ganeti in your production networks, so I want you to know what we're working on and what the next features will be. So, what's Ganeti? Basically, you have Xen as a building block. You might want to use it rather than on a single box in a cluster, possibly using failover, but you don't have or you don't want to buy a SAN to store your instances on and things like that. What we do is tie it with DRBD and build a purely open source based cluster management technology without any need for special hardware, without any need for RAID on the machines. You can just use your desktops and put them somewhere and start using them. And we want support for different type of host systems because we have different customers that have different needs. And we want to manage at the same time tens of nodes and hundreds of instances because we don't want to manage each node at one after the other, but we want to have a unique cluster system. So what do we do? Basically, we have, this is a Ganeti cluster. These are the physical nodes, the DOM0 in Xen terminology, and then we have the virtual systems. This is one virtual system. It has a virtual disk, which is actually a DRBD device between system 1 and system 2. So what you can do after this is you migrate the system between system 1 and system 2. Right now, this is a non-live migration because we needed some features in DRBD8 in order to do live migration. Now we have DRBD8 in the latest version, and we will implement live migration later, but for now you have to switch off the system and restart it on the other system, even if Xen supports live migration, but it does only if you have SAN and not with these DRBD things without some changes. So this is how to use Ganeti. It's very simple, it's very straightforward. First of all, you init the cluster and say, this is my new Ganeti cluster. Then you can go ahead and add your nodes. So this was node 0. It's already added to the cluster. Then you add 1, 2, and 3. And then you have one cluster. So you can, for example, install a system on all nodes or do things like that. And this is the package that contains a Ganeti instance, which actually will be needed in order to set up our cluster. So this is the cluster setup. After we've set it up, we can just go ahead and use it. So we can create instances. This is an example command to create instances. There are a lot more options, RAM, swap space, disk space. But for now, let's keep it simple. You can create a normal instances with default options. And then you can, for example, after a node crash, you can fail over the instance to its secondary node. So it was on node 2, you fail it over to node 1. And then you can replace its disk and move them to node 3, so the instance will be rated again, while before it was only on one node if the node had crashed. Of course, if it was just a downtime, then you can bring the node up again, and you don't need to do that. It all depends how bad the node crash was. So, and then you can basically query your cluster status, query which instances you have, what are they doing, how much memory, how much disk space. This is an example list. Then you have other fields. You can ask for various information about instance configuration. And this is the status of all the nodes in the cluster, so you can decide where to allocate your instances and things like that. Now, what can you do? This is the whole Ganeti, like, in a short version. You have a GNT node command that lets you manage the nodes. GNT instance lets you manage the instances. The OS command basically lists and queries the operating systems you can install on the instances. For example, you could install Ganeti on Debian, but have Red Hat, Gentoo, and Debian images for your customers or whoever to use. and you have global cluster commands and an instance import-export tool in order to back up an instance to some other disk and then re-import it back or re-import it back with some changes. So let's go a bit into the detail of an instance failover. First, this is the normal cluster status as we've seen before. Then what happens is that system 1 has failed. So as you could imagine in Xen, if the DOM0 fails, the vert system is down too, and it's crashed. But we have luckily a copy of the data, so if system 1's motherboard has failed, for example, and we don't have a system 1 anymore, or all its disks have crashed because you didn't have RAID on system 1, it doesn't matter. We can just run the failover, and then virtual system will be rebooted on system 2, which will have a copy of the data as of the crash. So it will basically be as bad as a power unplug, but not as bad as having lost all your data. Of course, this supports only a one node crash out of the whole cluster, or more if you're lucky, but we can't guarantee more, because if you have instances like node 1, system 1 and system 2 crash, then you've lost actually the virtual system 1, and you can't do anything about it. So then what we do is replace disks. So this, of course, is the wrong arrow somehow. The real copies from system 2 to system 3, because we have no system 1, but theoretically what you have is you move your secondary disks from system 1 to from system 2, and then you have your virtual system redundant again and ready for another failure. So after you've done this and you've reduced basically your cluster size, you can support another one node failure as long as you have enough RAM and enough resources to host all your instances. So this is the basic ganeti, what it does right now. We have some optional features which are considered advanced for various reasons. For example, the RBD replication normally runs on the same network as the instance traffic is. You might want to put it on a separate network for speed reasons, like if you have 2 network cards on the nodes, why not use the second one for that? Or you could have different instances in different bridges. For example, rather than creating only one Xen bridge, you create 5 of them connected to different routes, different firewalling policies, instances that have not to talk with each other, and then you connect them. This is an example of it, like green instances all talk to each other, magenta instances talk to each other, and the blue instances on a network by itself and doesn't talk to anybody. And here the disks are connected to a special interface, a special switch, which is just for replication, which increases your performance during replication time. And then you have tagging. You can tag instances or nodes with labels, and then look for them. If you need to make them special for any reason, all the instances belonging to one customer or something, you tag them. So this is basically what we have till now. Then that's what we're working on for the next version of ganeti, which we don't know yet when it will be released, but we're aiming at sometimes in the second half of this year. First of all, what we're doing is a job queue. So right now you have to create instances or do things one after the other. And people, of course, want to create big number of instances, so just script it and run it serially. We want them to be able to say, submit a job and then query the job status later. And we want to be able to run these jobs in parallel. Also right now, as every project starts, we have one big lock and only one ganeti command can run at a time. We call it the big ganeti lock because of historical reasons, of course. And then we'll want to have granular locking. And for example, if you want to create instances on 2 different nodes or set of nodes, there should be no reason why this wouldn't work. So we're working on that. Another thing we're doing is a remote cluster API. So right now you have to SSH to the cluster and actually type your commands. But what if you have a web interface to control the cluster or something like that? We don't provide that now, but some people might want to build one. So we want to build an API that allows you to control the cluster. And maybe in the future, even single customers to control single sets of machines, but that's not in the first 1.3 release, as a release target at least. Then if someone has patches, of course, that might happen. Another thing that was asked is file-based storage. What ganeti does now is it requires you to have an LVM disk and allocates the instance disks on LVM. So this works pretty well for the RBD, but if you actually do have a SAN, it was reported to us that it becomes tricky because you would need either to have a cluster file system. Anyway, it becomes more tricky than just storing the instances on files and letting the SAN deal about everything else. So what we are going to do is allow you to say, put them in this directory, and then you'll manage your SAN, configure it, and take care that it's visible from the other device for failover. We won't, but at least it will allow you to use ganeti together with that. Then we'll have a possibility to customize your instances a bit more. As we said, now you can install different operating systems, but instances are kind of limited. You have one disk, one ZOP, one network interface. That's all. You can hack in the ganeti config file manually to have more. People have successfully done that because they needed it, but it's not quite intuitive, and basically you have all the support inside ganeti but not in the interface. So we're planning to polish the interface and letting you having special instances with two networks connected to two bridges if you want to do like VPN central points or things like that on ganeti. You'll be able to do that after this change. Then we want, of course, to have live failover. Now we don't have live failover because DRBD 07, which we were using before, works in master-slave master mode, so you couldn't fail over the instance without tearing down the DRBD device and re-enabling with a master change to the other node. DRBD 8 can work in master-master node, but we don't want to do that because people will log into a node and just mount the disk for debugging while the instance is running on the other node. They don't have cluster file system and everything will break. So we want to keep with master-slave nodes, so the disk on the slave node is just read-only. But what we want to do is to add the possibility to change it at runtime. So when you will fail over lively an instance, we will change this because we don't need to tear off the whole DRBD stack anymore, and so we can do live failover in the next version. And then we want multiple coexisting hypervisors. Right now only Xen. In the latest versions, you can have Xen or Xen HVM, so running Windows or other operating systems altogether, not just the versions of Linux with the Paravir tops or anyway paravirtualized. So with multiple coexisting hypervisors, you can run those together, but you could also be able to run KVM or VirtualBox if we will have a module for that on the same box or on the same cluster. Now we have a module for the hypervisors. We are only supporting these two, and we don't allow you to basically use more than one at the same time. So one cluster is tied to its hypervisor. We want to implement more, and we want to make them coexist. So also instances can have different parameters depending on which hypervisors and things like that. And then what we want is a multi-cluster management, but that's later. After 1.3, we want to use the remote cluster API to have a multi-cluster manager in order to decide which cluster to allocate your instances on in a central point external to ganeti. But that's also something we plan for a lot later, and we don't know when it will be released. And that's basically it. Thank you very much for your attention. And if you have questions, we have 2 minutes now, or you can follow me outside for other follow-ups. Or just send a mail. We have a mailing list. I didn't publish the website on this slide, sorry. But it's code.google.com/p/ganeti, or just look for ganeti on Google and join the mailing list, talk with the development team, send issues, try it, and let us know what you think about it. Thank you very much. Do you have any questions? Yes. Yes, you have to do it manually. You could install some monitoring system that fails over for you, but right now we have no integration with Heartbeat and checking the node uptime and so on. What we do is basically, if a node is down and instances are down, someone gets paged and fails over the machines, but at least you don't lose anything. It's better than failover, failing for physical hardware, but it's not automatized for now. You could plug it to some automatic system that just runs the command. Like plug it to a Heartbeat or something. Thanks. Yes. Yes, the cluster knows, all nodes know about the whole status of the cluster. So if you lose the cluster master, you can fail over that one to another node and you will have all the status. You're welcome. Thanks. Other follow-ups outside?